Okay, so let's pull that up and take a look at those 6 problems that you looked at. Very good. Okay, so there we finished off on this right here, and this is what we talked about. We talked about you can memorize all 4 of these, but it's a lot easier to just look at this and say, okay, if the x is squared, it's going to open up or down. If the y is squared, it's going to open right or left. And notice that both of these have a vertex at hk, and which variable is the h always with? It's always with x, and the k is always with y. So don't look at this one right here and say, oh, whatever this number is, I'm going to write that down first. People make that mistake all the time, so please don't do that. Okay? And then the negative is going to tell us whether it opens right or left, up or down, that sort of thing. So if it's x squared, it either opens up or down. If it's positive, it opens up. If it's negative, it opens down. If the y is squared, it opens right or left. If it's positive, it's to the right, and if it's negative, it's to the left. And remember, if we graph these, we want to graph the vertex, the directrix, the focus, and we want to graph the endpoints of what we called the lattice rectum. And one nice thing was the lattice rectum was 4a units long. So whatever this number is right here, when we factor out that coefficient, that's how long the lattice rectum is. Okay, you don't need to worry about the negative. Okay, we just look at the number. Okay, everything we dealt with so far, I think, was positive. So let's take a look at a couple of these right here. On example 4, it says, find the vertex, focus, and directrix for the given equation of a parabola. Okay, we know it's a parabola because it's got just one squared variable. Okay, remember, we're going to be mixing these together in a couple days, so you'll have to be able to look at an equation and tell which it is. The x is squared, so up, down, right, left. Up or down, okay? Now, this isn't quite in the same form. This is, we normally write the x squared first, but it doesn't matter, okay? What's the vertex on this? Vertex would be 0, 0, okay? The number with the y, the number on the opposite side from the perfect square, is it positive or negative? Okay, it's positive. So if x is squared, it's the up, down thing, and we look at this over here and tell which it is. This opens up, okay? So we know the vertex, we know it opens up. We need to find the focus and the directrix. So let's just think about this for a quick second. Okay, its vertex is right there. We know it opens up, so we know it's something like this. Let's take a look at that. That is 4ay. So that means 4a is the same as 4. What's a? A must be 1. So that means we'd go 1 unit up here to get to the focus, and 1 unit down here to get to the directrix. So if you're at 0, 0 and you go up 1, where's the focus? Okay, x coordinate doesn't change, the y coordinate does. And what would the equation for the directrix be? Okay, it would be y equals -1. Okay, so here are the answers for that one right there. It said vertex, there's the vertex. We wanted to find the focus, there's the focus, and the directrix right there. Now, drawing a graph isn't necessary. It didn't say graph this, but graphing it, or at least visualizing what the graph would look like, that can be really helpful. Okay? All right, let's take a look at this one right here. Now, I'm going to ask a question, so let me get the whole thing out before you venture a guess here. Question is, right, left, up, or down? Now, I want a specific answer. Let's not categorize it as either up or down, right or left. Look at it, figure out whether it's up or down, right or left, and then of those two, look at the signs and figure out, well, gosh, I know it's got to be this one of those 4 directions, up, down, right, left. Question is, which one is it and why? Why is that the answer? So up, down, right, left. Who wants to tell us what the answer is? Samantha, you know?
I think I might know.
Samantha thinks she knows. What do you think the answer is?
I think it's left.
Samantha thinks the answer is left. How many agree with that? Okay, the answer is left. It does open to the left. Okay, we can narrow it down to 2 of them because we know the y is squared. If x is squared, that's a regular old parabola. We're used to graphing x squared. It's going to open up or it's going to open down. If y is squared, it's to the right or to the left. And Samantha, how did you tell that it opens to the left?
Because 12 is negative.
Okay, because there's a negative in front of the 12. Okay? And that kind of makes sense. If the choice is right or left, right is positive, left is negative. So if there's a negative there, it's going to be to the left. So we know it opens to the left. Okay, let's write down what the vertex is. The vertex would be 0, 0. Hasn't moved anywhere. Okay, so we got that taken care of. Let's draw a quick sketch. 0, 0, and we know it opens to the left. So we know it's going to curve around like this. Okay, now we don't have to graph it, so I'm just going to go ahead and draw a quick sketch of what this would look like. It's going to look something like that. Now the question is, where is the focus and where is the directrix? So the directrix is going to be over here. The focus is going to be over here. Question is, how far? I don't answer that yet. Okay. Again, I want to emphasize this again because this is going to be helpful in the long run. The focus is always inside the curved part of the conic section. So here's the curved part of the conic section. Focus is inside, the directrix is outside. On a parabola, it bends away from the directrix around the focus. Okay? So, question is, how far inside is the focus and how far outside is the directrix? And the follow-up to that is, how do you know? How would you tell somebody else? Well, here's how I got the answer. Caitlin.
You do the same thing you do. Use negative 12, 4.
Okay. Good there. And what did you get for an answer there? Okay, she got -3. Everybody watch, please. This is totally fine. This is an okay way to think of it. The negative tells us what the direction is. We don't really care about the negative as far as A goes because remember what A is. A is a distance. Distance we always think of as positive. So I'm just going to say that this is 12 equals 4A. It doesn't matter whether it's positive 12 or negative 12. We already used the sign to determine the direction. The 12 is the important part there. So we'll take 12, set it equal to 4A, and we get A equals 3. So that means we go 3 units inside and 3 units outside. Now, do you see why we also don't care about the negative there? Because all we're saying is, how far? What is the distance that we travel inside to get to the focus and outside to get to the directrix? So if this is 0, 0, then the focus would be at -3, 0. There's the focus. There's the vertex. And we'd have to go 3 this way. This is going to be, that would be 3, 0, but what's the equation of the directrix? X equals 3 because it's a vertical line. Okay? So once we know that distance, again, we only care about how far it is. Okay? Then we can write down where the where the focus is and where the directrix is. Any questions there? Yeah. That 4 from the formula. Remember when we derived this number in front here is always 4 times whatever A was, and A is the distance from the vertex to the focus or the vertex to the directrix. Yeah, sure. Okay, anything else? Okay, let's take a look at this one right here. It says graph and label the following. Got to get all the important parts here. Let's see, Alex, up, down, right, or left? This is going to be up. Okay, what's the vertex? 0, 0. Let's see. Did we do this one already? No? Okay. All right. Let's see. A is what? A is 2. So we're going to go 2 units up and 2 units down. So this is going to be y equals -2, and the focus is going to be 0, 2. And if we're going to graph this and label all the important parts, what important part did we say we've got the lattice rectum, right? The LR. Okay. How long is the entire lattice rectum? 8. How far do you go on either side? 4. So I'm going to go 4 over here, 4 over here, and there's the right shape. Label this point, and we're in business. So that's 4, 2. And that's -4, 2. Any questions there? Okay, somebody over on the other side. Let's take a look at this next one. One of the 4 directions. Susie, which is it? This is going to be left. Okay, the vertex is 0, 0. Let's see, what's A in this case, John?
A is 1.
A is 1. Because we'd take the 4 and set it equal to 4A. That means A is going to be 1. So I'm going to go 1 unit here, 1 unit here. Okay, so here's our directrix. That would be x equals 1. Here's our focus. Our focus would be -1 comma 0. And JC, how long is the entire latus rectum on this one? 4. So how far are we going to go in either direction? 2. So we're going to go up 2 here, down 2 here. Here's our parabola that opens to the left. Okay, and then we'll just label these points right here. These all have an x coordinate of -1, so this is going to be -1 comma 2, and this is going to be -1 comma -2. And there we go. Any questions? Yeah.
So I didn't have a question.
We're good? Okay. Ready to move on? Yeah. Because this number right there is the length of the latus rectum. The latus rectum is 4A units long. So whatever that number is, that's how long the latus rectum is. That distance from here to here is the latus rectum. So if the whole thing is 8, I'm going to go 4 on either side. So I'd go 4 this way and 4 that way. That way the whole thing's 8 units long. Does that work? Okay. Anything else? Okay, good. Let's take a look at this one. Same questions. Which of the 4 directions, Charles? This one's going to be left. Vertex. Careful there. Careful. Everybody being careful. You're not going to make the mistake that a lot of people make on a test when one of these gets thrown at them. Find the x. What's with the x? A 3. So it's at -3. What's with the y? A 2. So the vertex is at -3, 2. So we go back 3 and up 2. That's the vertex. It opens to the left, so it's going to go like this. How far do I go? Let's see, 12 equals 4A, so A equals 3, right? I go 3 units in each direction. So 1, 2, 3. This is where the latus rectum is, or sorry, this is the directrix. And then I go 1, 2, 3. Right here, that's where the focus is. How long is the latus rectum? The whole thing is 12, so I go 6 on either side. So I'm going to go 1, 2, 3, 4, 5, 6 right here. 1, 2, 3, 4, 5, 6 right there. And the graph looks something like this. Here's our parabola. Not a very pretty one, but that's the parabola. We want to label everything. Directrix. X equals 0, because it's just the y-axis, right? The vertex, let's go ahead and label that again since we've got plenty of room on this one right here. -3 comma 2. This has the same y coordinate, so this is going to be, well, let's see, I backed up another 3, so that's going to put me at, whoops, -6 comma 2. Now, if I go straight up and straight down, one of those coordinates is going to stay the same. All 3 of these have the same x coordinates. So this is going to be -6, and that's going to be -6. From here, from right there, I went up 6 units. I was already at 2, right? So if I go up 6, that's going to put me at 8. If I go down 6, that's going to put me at -4. Okay, now take a good look at that graph. That is an excellent test question. It's not a parabola that we're used to graphing. Okay, doesn't open up or down. Okay, it's not one of those real simple ones where you've got 8 or 4 or something like that. Okay, a little bit odd, but we've got everything labeled here: the directrix, the vertex, the focus, and then the endpoints of the latus rectum. If you can do that on a test, you're in great shape. Okay, take a look at the next one. Don't say anything out loud. Write down where the vertex is. Something a little bit strange about this one. Okay, what's a little bit weird about this one? There's no parentheses around the y, and you have to have those. So could we factor something out? What if I said you had to factor something out? You can always take out a 1, right? You can just put parentheses around there and say, hey, the number out in front is a 1. Now, the question remains, what is the vertex? Don't make that mistake. Find the x, -1. Find the y, +1. Please, please, please do not make that mistake. We're going to see that same mistake with parabolas, ellipses, and hyperbolas. Okay, so please find the x. That's what h is. Find the k, find the y, that's where the k is. All right, so there's the vertex. Okay, what else is a little bit weird about this one? Okay, and yet that has to be 4a. Okay, what if I said this? How long is the latus rectum? It's 1. Okay, that number, okay, ignore the sign. That number is always how long the latus rectum is. So on this particular problem, the latus rectum is only 1 unit long. So if I do the same thing I did before, which is take that number and set it equal to 4a, what does this say a is? A is 1/4. So if the vertex is at, well, let's see, we didn't even say which way this opens. Which way does this open, by the way? Opens up. So if we go to this point right here where the vertex is, -1, 1, and I'm going to put that point right there. It opens up. A is 1/4. That means the focus is only 1/4 of a unit inside the parabola. So we're about right there. And that means the directrix is only 1/4 below it. So that means we're about, see if I can get this right. Okay, that looks like garbage, but that's it. There's the directrix. So if this is 1, 1, sorry, -1, 1. So if the vertex is at -1, 1, where would the focus be? -1, and then we went up another 1/4, so that's going to be, what did you say, Charles? 5/4. That's where the focus is. If we're at 1 and I go down a 1/4, what does that make my directrix? Yep. The directrix would be y equals 3/4. So there's the vertex, there's the focus, there's the directrix. Again, how long is the latus rectum? 1 unit long. So from the focus I go, well, wait just a second, it's not 1 unit on either side, it's 1 unit total. So how far do I go on either side? Half a unit on either side. So I'm going to go a half a unit over here and a half a unit over here, and this is what the parabola looks like. Now, to my eye, that actually looks more like what we're used to seeing. That shape, the ones we've been graphing are pretty stretched out, or let's see, vertically shrunk, okay, depending on the direction. Okay, that looks like a standard old parabola, and in fact, that is a standard parabola. Okay, now we can label these 2 points. That wouldn't be normally our choice for labeling, but remember, if this is -1 and 5/4, this is going to have the same y coordinate. Okay, it's going to be even with that focus there. So if I'm at -1 and I go forward a half a unit, what is that y coordinate right? Sorry, that x coordinate right here? -1/2. And if I'm at -1 and I back up another half unit, that's going to put me at -1.5 or -3/2. Everybody good there? Okay, take a good look at this. Is everybody all right with that? Everybody convinced we know what we're doing here? Okay, The 5/4, we were at 1 unit right here. There's where the vertex is. We're at negative 1, 1. And then we figured out that A is 1/4, so I have to go up another fourth. So 1 plus a fourth is 1 1/4 or 5/4. And if we go down 1/4, that would be 1 minus a fourth. That would be 3/4. Because remember, the focus is always inside the parabola. The directrix is always outside the parabola. That work? Okay. Anything else? Is everybody watching? Okay. This is how we would normally do this problem. If you took a good look at this, we'd normally write it as y equals x squared plus, x plus 1 quantity squared plus 1. That's how we'd normally write that. If we just move the 1 to the other side by adding 1 to both sides, you get y equals x plus 1 quantity squared plus 1. Where's the vertex for this? Negative 1, 1. Opens up. Stretched or shrunk? Is there a number in front there? Nope, it's just the regular old shape. So we'd go over 1 and up 1. From the vertex, over 2 and up, 2 squared up 4. Does that look like the right shape? Okay. Even using our old techniques, that works. Okay. But please don't do it this way. The only ones that would work that way is if they open up or down, and you'd still have to complete the square and all that sort of stuff. Please get used to them this way, because this is actually going to help in the long run. It'll help a lot when we do ellipses and hyperbolas. Okay, any questions? Okay, let's flip the page over and let's do these last couple. Got 2 problems to do here, and then we're going to look at a few problems from the assignment just to kind of draw some similarities between the assignment and what we've done in the notes. It says find the vertex, focus, and directrix of the given equation of the parabola, and then graph the parabola. So what's wrong with these 2 examples? They're not what? They're not complete. They're not in that graph-friendly form. Okay, that graph-friendly form was one of these 2 things right here. We either have to make a perfect square with x and get all the stuff with y on the other side and factor the constant out, or make a perfect square with y and get all the stuff with x over here and factor out the constant. Again, if y squared, which way does it open? To the side, right or left. Okay, and if x is squared, it's up or down, and then we tell what it is by whether it's a positive or a negative. Okay? So we need to make it look like that. We need to get it in that graph-friendly form, if you want to call it that. So I'm going to make this a little bit larger so you can see the work. Okay, which variable squared? X is squared. This is either going to open up or down. You can't really decide until you're done. So here's what we're going to do. We're going to collect the stuff with x's on this side. So x squared minus 4x. And then I'm going to move this to the other side. So that's going to be a plus 4y plus 4. Does everybody see that all that stuff was in there to begin with? Okay, next. Let's complete the square with this. Remember, you can't complete the square if there's a number in front of this, so you'd have to get rid of that. I don't think there are any like that. You can only complete the square if this is a 1x squared. It's got to be a 1. So I'm going to take half that middle coefficient. Half that middle coefficient is negative 2. I'm going to hang on to that. I like to circle it. I'm going to square that and add it to this side. Now notice that blue number 4 was not there to begin with. If I add 4 on this side over here, what do I have to do to compensate? Add 4 to the other side. This is like an equation. It's a balance scale. Add 4 here, you have to add 4 there. Now if I were keeping everything on the same side, I'd have to compensate by doing the opposite, but that's not what I'm doing here. I can mess with both sides of the equation if you want to think of it that way. So I just do the same thing on both sides. Everybody good there? Okay, here's what we've got. We've got x minus 2 quantity squared. That's why I leave that negative 2 there, because this is a perfect square of that variable and that number, quantity squared. And then over here, I've got a 4y plus 8. Now, we're almost there. I've got a perfect square with x, but I can't have a 4y. I need just a plain old y plus or minus some number. So what do I take out? Factor out a 4. So here's what I'm working with. X minus 2 quantity squared equals 4y plus 2. Now we can start asking ourselves the exact same questions. Where's the vertex? Where's the focus? Where's the directrix? Does it open up, down, right, left? All that sort of stuff. So we already established this opens either up or down. Which is it? Opens up. Okay, where's the vertex? Again, please don't make that mistake. 2, -2. Find the x. That's going to help us find the h. Find the y. That's going to help us find the k. Okay, then we need to find the focus. So let's go ahead and start graphing this. This is going to be at 2, -2, so we're right here. Let's see, what's A? A is 1. So we're going to go 1 unit up to get to the focus, and we're going to go 1 unit down to get to the directrix.
Wouldn't it be 1/2?
No. So that means the focus is at, well, if we're at -2, 2, -2, and we go up 1, that would be 2, -1. And if we were at 2, -2, and we go down 1, that's going to put us at y equals -3 for the directrix. Okay. And then, let's see, what else do we need to do to make the right shape? Latus rectum is going to be how long? 4 units long. That means I'm going to go 2 in either direction. So I'm going to go 2 this way, and I'm going to go 2 this way. So, whoops, even with the focus, right? Let's see, those endpoints, they shouldn't be too bad to label because they all have the same y coordinate as the focus. So that's a -1 and a -1. And I went 2 units forward, that'll put me at 4, and 2 units back, that'll put me at 0. Convincing? Any questions? Okay, I'm going to give you a 2 or 3 minute head start. Do the next problem. Check with your neighbor when you're done, compare your answers, see if you both got the same thing. If you did, you're probably right. Josh Noyce, what would we do first? Move the 2i to the other side? How come? Move the x. Yep, we've got a y squared and we've got a y. We're going to keep those together. Keep the y's together, keep the x's together. So we're going to move the x to the other side. So this is going to be y squared plus 2y equals, that's going to be a -x. Okay, Max, what would we do next? We are going to add 1 to both sides because that's half the middle coefficient. If I square that, I get 1. I'll add 1 to both sides. So this is going to give me a perfect square with y and positive 1, quantity squared. And then over on the other side, well, let's see, I'm not going to write it as a negative x. I'm going to write it with a positive x because I'm going to take out a what? Take out a negative 1. And I'm left with x minus 1. Okay, vertex. Very good. Careful there. Find the x. Opposite of that. Find the y. Opposite of that. Okay, now I'm going to scale this a little bit differently to draw this. Let's do one more question. Alex, which way does this open? Opens left. Okay, that one opens to the left. Guys, have we done any to the right? I should fix that in my notes. Okay, here's what I'm going to do. I'm going to scale this. This is going to be negative 1. This is going to be positive 1. 1, 2, 3, 4. Here's negative 1, and this is positive 1. Okay, that's going to make it a little bit easier to draw. So it's at 1, negative 1. So over 1 and down 1. Let's see, what's A in this case? But it's a distance, so it's just positive 1/4, right? So I'm going to go, and we already figured out it opens to the left, so I'm going to go 1/4 of a unit over here, and 1/4 of a unit over here. Here's the directrix. Here's the focus. And then how long is the latus rectum? 1 altogether. So that means we're going to go half on either side. So I'm going to go a half over here. And a half over here. And the graph looks something like this. Boy, that's ugly. Okay, now let's stop right there. If I wrote that on a test, would I get all the points? I should label things. Okay. First of all, let's label the vertex over here. Okay. The vertex is negative 1, or sorry, positive 1, negative 1. What's the directrix? X equals 5/4. Where's the focus? What's that?
Wouldn't the directrix be negative 5/4? Or no, never mind.
Okay. So the focus is right here. It's still at negative 1, but we went a 1/4 of a unit back this way. So that's going to be 3/4, comma, negative 1. And then these are going to have the same x coordinate. So they're both going to be, 3/4. And this is going to be 3/4. I went half a unit up, so that's going to be negative 1/2, and I went half a unit down. That's minus another half, so that's, that should be 3/2, sorry. Okay. Ugly fraction problem. Looks pretty nice to start out with. It probably wouldn't give you one that difficult on the test, but there you go. Okay, are there any questions?
What was the lattice rectum?
The lattice rectum, the entire length of the lattice rectum was 1 unit. So if the whole thing was 1 unit, then that's 4A, so A is 1/4. Okay? All right. Grab your books if you would, please. Take a look at page 740. Let's look at problem number 2. It's just a little bit of matching there. Okay, the choices are above A through H. Which ones can you automatically rule out just by looking at it and knowing where the vertex is? Of A through H, which ones can you automatically rule out for number 2 just because you know where the vertex is? Okay, the ones with x squared, why? It opens to the side. So anything with an x squared in it we can rule out. What else? Anything that's positive, that would work. And where's the vertex? 1, 1. So could it be any of the ones A, C, B, or A, B, C, or D? Okay, couldn't be those. Okay, it opens to the left, so it's got to be a y squared. So let's find one that's a y squared. That would be E and G, and it opens to the left. So which one of those two opens to the left? G does. Okay? All right. Take a look at number 18. The instructions, it says, find the equation of the parabola described. Find 2 points that define the latus rectum and graph the equation. Now, once we know what the equation is, we can graph things pretty well. Is this like any of the problems that we did here? Any of these examples? 1, 2, 3, 4. Wait just a second. Take a look at 3. Look at example 3. Okay, here's what 18 says. 18 says the vertex is at 4, -2, and the focus is at 6, -2. Isn't that kind of like what we did here? You didn't have to draw a sketch, but it can be helpful. Let's take a look at number 18. So number 18 says this. The vertex is 4, -2, and it says the focus is at 6, -2. Let's draw what this would have to look like. 4, -2. 1, 2, 3, 4, down 2. There's the vertex. The focus is at 6, -2. Here's the focus. Okay, now remember, yesterday I mentioned we'd have to really think about what was going on here. We're kind of putting pieces together. If the vertex is here and the focus is here, and remember I always said the focus was on the inside of the curved part of the conic section, could you sketch roughly what this would have to look like? It would have to look like that. That means it opens to the right. If it opens right or left, if it's a horizontal parabola, then it's got to be which squared variable? Y's got to be squared. So it's going to be y minus k, quantity squared, 4a, x minus h. And would this 4a be positive or negative? It's going to be positive. This is the right formula right here. Okay? Now, if I know where the vertex is, that is h and k right there. We can plug those in. So this is going to be, again, be careful, y, what is it? Plus 2. Y plus 2. There's the k. That goes with the y. So it's a minus minus 2. This is going to be 4a, and then I have x minus 4. Okay, now take a good look right here. It's almost done. What's the only thing we need? We just need a. What is a on the graph of a parabola? Okay, and in this case it's 2. It's the distance between the vertex and the focus and the vertex and the directrix. We know what this distance is because this is 4, this is 6, so that means a's got to be 2. Once you know a is 2, we can plug this in. So this is y plus 2, quantity squared. That would be 8 and x minus 4. Now, that's the equation. They also want you to finish graphing it, have the endpoints of the latus rectum, all that sort of stuff, so we could figure out where those are. Okay, so you could figure out that point and that point, because, well, let's see, this is 6, -2. They'd all have an x coordinate of 6, and how far would I go in each direction? 4, okay? 4a is 8. The distance, or the length of the latus rectum is 8. So I'd go down 4, that's going to put me at -6. I'd go up 4, that's going to put me at +2. Okay, are there any questions there? Okay, take a look at problem number 44. Which variable is going to be squared on 44? Oops, let me change colors here. 44 looks like this. Oops. 1, 2. Charles, which is it? X is going to be squared. So it's going to be x minus h, quantity squared, 4a, y minus k. Positive or negative? Negative. Do you know h, a, or k? Do you know any of those by looking at what they gave you? You know the vertex. You know the vertex is 1, 2. So I can fill this in. X minus what? 1, quantity squared. Negative 4a y minus 2. Now, how do you figure out what a is? They gave you one other point. That other point was 2, 1. Not necessarily. Okay, they didn't say that's the end point of the lattice rectum. So if this point is on the graph, what must also be true? Point is on the graph, then it works in the equation. So I can plug that in for x, that in for y, and solve for what a would have to be to make that true.
Can't you show up 1 and then, like, if something's over 1, 1 then should be 1? Like, if you just go up 1, wouldn't that be the focus?
No, not necessarily. No. So that point right here that's even with this, it's not even with the lattice rectum. Okay. In fact, on this one, I think it would be, I think a is going to turn out to be 1/4. Okay. Not certain, but I think it does. Okay. And the last one I want to take a quick look at, and then you can have a few minutes to work, is problem number 58. Okay, 58 says a searchlight is shaped like a paraboloid of revolution. Okay, light source is located 2 feet from the base along the axis of symmetry. And the depth of the searchlight is 4 feet. What should the width of the opening be? Okay, I did say 58, right? 51. Oh, 51. Okay, let's take a look at 51. That sounds better. Same type of thing, satellite dish. Satellite dish is shaped like a paraboloid of revolution. Okay, if you have, how many of you have satellite TV at home? If you look at that dish, it's kind of curved. Guess what that shape is? Okay, it's like you had a parabola, and then they took it and they spun it around and made 3 dimensions out of it. Okay, so that dish is it's a parabolic reflector is what it is. So this is what we've got here. Satellite dish is shaped like a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point. So here's what happens. Okay, and I'll just draw this in 2 dimensions. Okay, when the cool thing about a parabolic mirror or a parabolic reflector is any light or any waves that come in here, they'll hit and they'll go bounce to this point. These will hit here and bounce to this point. These will hit here and bounce like that. Guess where they all bounce to? Okay, and what set the receiver? Not the vertex. The focus of all of those waves, of all of those beams, it's going to end up there, and that's where the receiver is. Okay, so that's why a parabolic mirror is so helpful. If you watch like NFL games, they'll have parabolic microphones on the side. They'll have a microphone, and then they've got this big plexiglass shape around it. That's in the shape of a paraboloid of revolution. It's in a parabolic shape. And any sound that comes toward that microphone hits that dish and bounces toward, what do they put at the focus? They put the microphone right at the focus. Okay? So pretty cool. So here's what it says on this one. It says, let's see, if the dish is 10 feet across at its opening and 4 feet deep at its center, what position should the receiver be placed? So here's what we've got. We've got a parabola, and it tells us something about this. It says it's 10 feet wide across at the opening. So this is one of those gigantic dishes, okay, and it's 4 feet deep. Now, where is the best place to put the vertex as far as making it easy to graph? 0, 0. Okay, so there's 0, 0. If this is 10 feet across, how far do I go on either side? 5. So that's 5 comma something, and that's negative 5 comma something. And it says it's 4 feet deep. So this is 5 comma 4 and negative 5 comma 4. Now, listen carefully. Are these the endpoints of the lattice rectum? No. It would be nice if they were. We'd know what the equation is right off the bat. Okay? So these are not the endpoints of the lattice rectum. These are only points on the parabola. Okay, but you can look at this and you can tell me, because this is a parabola that opens up, which variable is squared? X. And because the vertex is at the origin, what are h and k? 0, 0. So this is going to be x squared equals 4ay. That's the equation, right? The focus is going to be right here somewhere. How far is it from the vertex to the focus? On any parabola, how far is it from the vertex to the focus? We have a name for that distance. A. Do we know what A is? Not yet. But can you take these points and plug them in and find what A would have to be?
Yeah.
Yes. Okay. So here's an X, here's a Y. Plug it in. 25 equals 4A times 4. 25 equals 16A. What's your answer to that? 25/16. That's going to be like 1 9/16. Okay, the question said, if the dish is 10 feet across at its opening and 4 feet deep at its center, at what position should the receiver be placed? So if they want to put it at the focus, how far above this bottom of the parabola should they put the receiver? 1 9/16 of a foot. Okay? All right. That's good. Have a great day.
Okay, how did you pull the X and Y?
This is X. Oh, yeah. This is X. This is Y. So that's 5 squared. 4 times A times 4. So we have 25 times 2. Yeah. Yeah. Mm-hmm.